How rusted solid should this be? Oh, there you go. Oh, that's a good clutch. Slightly better. Much better. I might need a bigger stabby. There you go. Nice. That's a partial fill block for racing. Hi, I'm Jamie. This is Dead Dodge Garage, and this is a rusty 318 that somebody left out in the rain for a month or three. You look proud of your accomplishments.
I am.
Until fairly recently, this was still an entire truck. Allan and I have been working on disassembling it to get down to the pieces we need for another project. I have sold a bunch of components off this truck, helping to fund future endeavors. The rear bumper and the rear axle are just a couple of those. Something like a month ago, I finally made a deal for this 1979 Power Wagon. I pulled the 360 out and in an Engine Wednesday video, tore it down and found all kinds of horrible stuff. There's the number 8 piston, and it's got some custom ventilation. This one is impressive. This one's worthy of a frame or something. Forget the head gasket. I'm framing this. I knew right then I wasn't going to be reassembling that engine to go back in this truck. Then I had a thought. What if I use this random 318 core that was sitting on this now bare frame right next to it, getting filled with rainwater? It's been quite a while since I tore into this engine, attempting to fix it and get the black Power Wagon up and running again. During the filming of that project, I found a bunch of big chunks of metal in the oil pan telling me that some bearings in this thing must be cooked. Probably cam bearings. That shouldn't be in there. But neither should any of the other chunks. Yikes. Here's that random chunk of thread. There's another one there that's slightly bent. And then all of this, which I believe is a bearing. There's an oiling hole. So that ain't good. And that was the final nail in the coffin for the 78 because it just wasn't worth overhauling an engine for that truck. The roof was made out of Bondo, the floor was made out of rust, all kinds of other stuff was made out of rust. The truck had been rear-ended and just in general was not doing too hot. And so this engine has been sitting with the timing cover and oil pan off for quite some time. It did have a wind intake manifold, but I sold that. So the valley's now been open for like 6-8 months? I don't even know. I did grab the glorious Mickey Thompson valve covers to use on another project. I haven't done that yet, and now I'm thinking they might just go right back on this engine, but we'll get to that a little later. Now don't yell at me when I tell you that earlier this year I scrapped like 4 318 cores. I had been storing those things forever and paying for it, and I was tired of looking at them. When we cleaned out my storage unit, I sent those away to be turned into Kias or whatever. I didn't figure I'd need a 318 core anytime soon, and now we're here. Okay, I actually do have one other good 318 core in stock. It's that one, which is currently wearing my 340 cylinder heads. That's the engine Dale put in the Demon when he blew the 340 up in 1975 or whatever. And it was in there for decades. I'm not going to do anything with that in the near future, but I'm going to keep it around. You just never know. Thanks to my recent infatuation with 273s, I have 4 of those. But yeah, 318s are kind of in short supply. I like 318s. I always have. And they make good engines for pickup trucks. Some people seem to think they're vastly superior to 360s for this application. I personally disagree and think that makes no sense at all, but I do think they're very good engines. And this one always ran pretty well in that Power Wagon. Until it didn't. In a series over the last 8 months, I rebuilt Mark's 318 for this 1968 Barracuda with some choice performance parts. And that engine turned out great. So I got to thinking, what if I could replicate that? It would have to be cheap. Like super, super cheap. And I'd have to use components I've got in stock. The big thing for that engine was a set of closed chamber heads. I have some. We put a mild cam in that engine. Well, I've got one of those too. We're gonna need a dual row timing chain, obviously, and a performer intake manifold. This Grimy unit should do the trick. Obviously, we'll need a 4-barrel carb. Maybe we'll pick one of these. I've got some options. We'll actually have one important advantage in the truck compared to Mark's Barracuda, and that is a set of long tube headers. As much as I hate them, well, they're already here, and they'll be great for the horse ponies, so we're going to leave them. We are not going to leave this 727 automatic transmission. Nope, we're going to use this NP435, which I think Allan's currently trying to drop on his toes. So yeah, that essentially means we're just taking the complete drivetrain from the 78 truck and popping it in the 79 truck, but with some cool hop-up parts. Nice. Now, before we started filming today, for some reason, we yanked the 318 core out of here with the tractor. That was a debacle. It didn't want to come off of the transmission, and while I was pulling on it, this happened. It all worked out, but still, kind of not smart. I was further encouraged to take on this project by that super nice factory 318 we went through for Allan a couple weeks ago. That one looked great, and I'm sure this one will be just as good. Obviously, this thing is already kind of sort of half torn down, so I'm just going to continue that. I'm not going to film every moment of it. You've seen us tear down a billion small blocks at this point. But as I find interesting things, I will point them out to you, and hopefully before too long, we'll have a naked block sitting here. Okay, one interesting note right off. The cylinder heads have been off of this engine. You can tell there's a fresh coat of blue paint on them. And the hold down bolts for the valve train are not stock. And I'm not doing this right. I think it's got stock springs. Rockers are off, push rods are out, lifters are out. Notice the tarnish here at the bottom. That does make it a little difficult to pop these out, but they all came. There were a couple that were pretty stuck and gummed up. The lifters might have come right out, but the intermediate gear is sure giving me a fight. I got it about that far, and that wasn't easy. It does not want to come out. It's kind of seized now, so we're going to hit that with some PB. We'll knock it back down, spin it up, turn it around, and screw with it for the next half hour. Some of these lifters look like this. Most of them look like... hold on. Okay, maybe they're all just rusty. I don't know. With that one wiped off, it kind of sort of looks okay. We'll save these as refacing candidates. I've got a bunch of those now. Here's the camshaft out. Yes, it's kind of crappy and rusty too. Probably a good regrinder core anyway. Now I see a little bit of scraping on the number 1 bearing journal. The others mostly look fine. Mostly. Looking through the cam tunnel, I honestly don't see much that worries me. Except for this number 1 bearing here. It's not the greatest. I've seen worse. I've run worse. Even in this crappy shot, you can see there's kind of some stuff going on the cam bearings back there. Why didn't I see it here? No idea. Rose-colored glasses, delusions. We'll get back to this a little later. If not from a cam bearing, where did that horrible flaky metal stuff come from? We're gonna find out in a bit here, I'm sure. Here's the technique for this. It's a 90-degree hook thing, a big flathead screwdriver, and obviously a bunch of magic penetrating spray. Allan's been fighting this for a bit now, and he has made some headway. You can see the gap we've got there now is, what, 1.5 inches? But it's certainly not out yet. Hey, don't stab yourself. That hurts. Don't burn your fingertips either. Yay! We might reuse that, but of course it doesn't have a pin. Anyway, I'm gonna get some of the big chunks out of here real quick. This is probably premature, and because I'm getting excited cleaning stuff, I'm gonna find like horrible damage in the bottom end. Well, there's our first cylinder head off. This is a composite gasket. Kind of already knew that because the heads have been off. There's some rust here. Kind of already knew that too, but luckily this piston's almost all the way up, and so this is gonna be right at the top of the chamber if there is any pitting or damage. We can live with that. And this hasn't been this way for long. Honestly, it'll probably be fine. Here's your weekly reminder that small block Chrysler engines kind of suck, and they always leak right in this area of the head gasket. Other than that, this gasket's fine. If it was steel, we'd be reusing it right now, but no. Now there's actually something else interesting in here, and that is horrible valve contact on every single piston at every single valve. That is really, really bad. Is that because of the timing chain situation? The nylon gear for the camshaft stripped out, and so this engine was just cranking with no action. Would every valve be able to contact in that case? I don't think so. There's the other head off, and it's exactly the same. Every single valve has hit every single piston. That is amazing. Notice they're pretty shiny. No carbon has built up in there. So did this just happen? Did this happen as the engine was dying? Maybe. As I understand, this truck drove to where it was and then simply wouldn't start the next time, but maybe I'm remembering that wrong. No rust on this side. We do have a bit of water here and some horrible slimy stuff. Yeah, slimy stuff. But does the crankshaft do that thing we like? Yes. Oh, good. So I think we got away with it. Well, okay, it's not the prettiest of things. This is like that one cylinder on the van 360. Yeah, it'll hone, probably, maybe. Most of it's right at the top. Now this is kind of cool. This one is making some horrible creaking sounds. They're not actually coming from here though. They're coming from the big end of the rod. What a weird thing. Now you can see some tree debris down there. I don't know if it's that. I don't know if there's rust down there now. Something's going on, but we'll get to the bottom of it in a minute. It's upside down now and it's piddling. And this is cool. This came flying out of the oil pickup as I turned the engine around. That is one of the little tang things that locks the valve cover gasket into the valve cover. This is a factory piece, I think. It's got factory paint on it. It's actually rubber and not cork. It's very, very brittle. So whenever they had this thing apart, they did a little whoopsie and dropped that down into the engine. Now I hardly even looked at these heads when I pulled them off. Allan happened to notice some white buildup on this spark plug. Pretty sure this is all coolant. You can actually look and see green staining there around the entire chamber. Well, look at this pattern right here. Pretty sure it's like broken in here, not sealing very well. Yep, and pulling coolant right through. As nice as the gasket looks, this is weird. You can even kind of see the circle all the way around the chamber, but there's obvious wetness right there. It had to be coming through there. Well, unless this head is cracked or something. Ooh, or the block could be cracked. I was told in a comment on the video about Allan's engine that trucks did not get a VIN here on the VIN pad. This doesn't have one either, so I guess that's correct. It does have a casting date of 1/10/78. That seems pretty late for this truck. This truck is a 78, but it's early enough that it doesn't have amber turn signal lenses. Usually there is a lead time between the casting date and when the engine was assembled of at least a few months, so I don't know. It's probably original, but we really have no way of knowing. Wow, look at this rod bearing. It's absolutely mint. I have a couple spare forged cranks for 318s and 273s, and so I'm kind of planning to use one of those and not this factory cast piece. But it looks so nice so far. Because I'm putting a stick transmission behind it and I do plan to do dumb stuff, it's hard shock loading that can break these things like twigs. And that wouldn't be good. See that date code? 11 of 77. I didn't even clean the top of the cylinder and these pistons are popping right out. These rings are beautiful too. So shiny. In case you were curious, I am not only human, I'm capable of being a pretty dumb one. I just accidentally knocked this number 1 piston off the block onto the ground and dinged it here. Luckily the ringland isn't damaged. Of course I'm upset about that because at this point, as nice as all of this looks, I think I'm like legally obligated to reuse it. And then I dropped the number 2 rod cap because the nuts weren't on yet and I thought they were. This is not going well. This should fix it. Oh, need more hands. Thank you. First damage I've found on rod bearing number 4, and it's very minor. You can see the one scratch in there. Nothing I'd be worried about at all. Okay, here's rod bearing number 5. Notice the big groove in that one, and also evidence of water intrusion. It's kind of rusty. There's buildup on here, which I'm kind of scraping off with my fingernail. Yeah, that's interesting. It felt horrible at first, but it kind of feels better now. That crappy rod bearing was on number 5. Number 5 is also the only piston that has been difficult to get out. And that is because it was the one with that water and horrible rust in it. I did get it out carefully. Yeah, you can see there's some crap jammed into those rings and they're kind of stuck in the piston, but I'm confident they'll come free. Oh, this is neat. I don't know where it came out of, but this is that same material I found in the oil pan that made me think this thing was like blown up. Sure looks like a piece of bearing material or something. It's pretty ugly. I found it sitting like there. I don't know where it came out of. Sure I do. It was wedged into the rod bearing, or between the big ends of the two. That would have been the horrible creaking noise. And why I didn't realize that when I was doing this, I have no idea. Number 8 was the other one with water in it, but no horrible rust. You can see a little bit of rusty stuff on the oil control ring there, but both top and second rings are moving free, and this one looks pretty darn good. And that's all 8 pistons and rods out. Other than number 5, they're all looking great. You may notice I hand numbered these. It's pretty common to see numbers on the rod and cap in engines like this, but those numbers are not in the cylinders they came out of. This one is a little weirder. It has logos on the rod and cap. There you can see a kind of plus sign thing, Maltese cross, diamond, square. So yeah, there's a random little logo thingy on each one of these instead of a number. Never seen that before, no idea what it's about, but I'm pretty sure it's original, judging by the date codes on these bearings and everything else here. Breaking the mains free now, and I really don't know what to expect. On the one hand, everything has looked great so far. On the other hand, I kind of need to explain where those metal chunks came from. Okay, things are getting weird. Number one has some wear. It's not the worst I've seen, but there are some little pitty things. Number one journal, little scraped, livable, but a little scraped. Number two looks like this. Notice the obvious stripes in the middle there? They kind of match the groove that's in the top shell of the bearing. Look at number one shell again. It has a groove. This had a fully grooved bearing on number one. It also had one on number three, and number five is always fully grooved. Number two and number four do not have the full groove, but number two has this weird debris. It's like it was making its own groove. Number three has the thrust surfaces on it. They kind of look okay. I never did check the thrust on this crank before I started loosening things. Looks like it might be kind of big, judging by that gap, but anyway. Number three main journal is roasted. It's really bad. Number four journal's fine, and number five is beautiful. I've lifted the crank out now. The upper shell for number one looks just like the bottom one with the weird little pitting stuff. Number two is kind of more the same. There is a groove here, some little bits of debris, and that's like a ding. Number three is much better than the bottom, but there is some scrapage here. Kind of looks like little bits of debris were getting shoved in through the oil hole and then running around the crank. Number four main kind of looks like number one. Number five upper shell, a little bit of debris, but still pretty good. The difference between the rod bearings and journals on this crank and the mains is amazing. I mean, listen to this. Something important I want to touch on here before we move on. The number three main journal was the one that was really, really toasted. And the one rod bearing that was damaged, number five. Number three main journal happens to feed oil to rod bearings number four and number five. So I'm thinking a bunch of the debris that was obviously getting crammed into number three main here was making its way to number five, and that's why that looks the way it does. Now that is kind of unfortunate because for a minute there I thought we were going to have a beautiful, all-original, never machined 318 cast crank. We don't. That would need a trip to the machine shop to be reused. It's kind of okay though because I really wanted to use a forging anyway. And I happen to have one right here. I pulled this out of a 273 that to my knowledge had never been machined. This should measure out at factory sizes, and the journals all look really good, except for some very mild rust stuff. That's from sitting in the shop. According to the world's cheapest measuring device, these two cranks do measure the same at 2.49 inches on the mains and 2.11 or so on the rods. Apparently the factory spec for the rod size is 2.10 and the main journal is 2.49. Why I got 2.11 I don't know, but I got it on both cranks, and again, world's most reliable measuring equipment. Now there could be one little problem, and that is that this is a 273 crank, this is a 318 obviously. There may be a piston weight difference, and so from the factory these things may have been balanced differently. This is according to some reading on the internet, and we all know the internet is always correct. Now it should come as no surprise that a 318 piston is a good bit larger than a 273 piston. However, the 273 from the factory used a super chunky wrist pin, which you can see right here. And my understanding was this was to raise the weight of the 273 piston to match the 318 poly piston. Because of course the 273 used the same crankshaft from the 318 poly. Man, I used to have a little hanging scale for checking this sort of thing, but I have no idea where that's gone now. You might think I'd just have one of those little digital scales laying around, but I've never been a purveyor of illicit substances. Anyway, I found a fish scale. It's in pounds and kilograms, so it's not quite granular enough for what we need here. It shows them both being very close. The 318 piston might be a hair heavier. If anything, this is the 273 piston, and they're very close. The difference we're looking for, if there is one, should be like 50 grams, maybe? So yeah, we're probably not going to see that on here. For fun comparison, here's a poly piston right in the same little spot there. This is missing rings. Now we're talking. That's a 440 piston. Here's the piston and rod for a 360 I'm building. This is aftermarket, so it's lighter. Not a whole lot lighter, but a little bit lighter than the 318 and 273 setups. And here's a 426 Hemi piston and rod, the heaviest of all for obvious reasons. I don't even know why I have a fish scale. I don't fish. Anyway, as near as I can tell on that scale, these two weigh the same. In a perfect world, we would have this entire assembly balanced. I know that. You probably know that. I had that done for my high performance 273 build here. But that is not in the cards for what we're doing today. I think we can probably just throw this together with that forged 273 crank, and as long as I keep it under 6 bajillion RPM, it's probably going to be fine. Will it vibrate? I don't know. Let's find out together. I certainly wouldn't mind using a set of factory 273 connecting rods. Unlike 318 connecting rods, in most years anyway, these are bushed inside for full floating piston pins like these. Notice the clip there. I happen to have like 3 or 4 sets of these, and I'd be happy to donate a set to this engine build. Unfortunately, to utilize these, we have to have a groove in the piston to use those clips. And the factory 318 pistons aren't going to have that. Now, I do have a set of 318 pistons with grooves, and they even came with the clips, which is pretty cool. Unfortunately, these are in the 20 thousandths oversized. They also probably weigh not the same as stockers, so we're not going to be able to use these. My budget for this operation is like nothing. The cost of gaskets and fluids, that's pretty much all I want to put into this deal. Okay, maybe some paint. We'll see. But I certainly don't want to have this block bored. I certainly do not want to have the crank balanced. So we're going to work with what I've got in stock. Now, obviously, we're going to need some main bearings. Well, that's okay because I happen to have an entire box of them. These are pretty much all standard 318, 273, 340, whatever, main bearings. Here's some standard 318 half groove. I'm probably good with that. This box of bearings actually came from the estate of legendary Pacific Northwest Mopar drag racer Dave Wren. And I've actually found in at least one of these boxes that he went in and removed the grooved halves to make race sets out of. See, typically high performance bearing sets will have full grooves in the main bearings. So I'm definitely going to carefully check each one of these and make sure they are right. Well, that's interesting. This set actually has full grooves on every single bearing. Why are they labeled half groove? Don't know. Here's another set. These actually are half grooved, as the label implies. Now the billion-dollar question is, do I use these or do I use the fancy full groove ones? I think I'm going to save these for something better. We'll use the cheap ones for this build. I think that's all it deserves. Now, of course, I need one rod bearing. I do have a good few stock ones. Most of them were removed from 273s, and most of them kind of look like this, which I'm not all that excited to use. Unfortunately, my magic box here is full of main bearings, 0 rod bearings. So I ordered one standard size Clevite rod bearing. O'Reilly will have it tomorrow at 1 p.m. for $6.83. I also ordered a complete engine gasket set that was $90. While I was thinking about it, I remembered there might have been something goofy with the double roller timing set I have, so I did order another one of those as well for $44.95. I'd order core plugs, but strangely, these look really, really good. Obviously, we're going to be putting a new rear main in this thing. That was definitely leaking. There's a horrible oily mess back here. Note, this seal is actually offset a little bit from the parting line there. Some builders like to do that. I don't. Certainly not with the modern seals anyway. I think this is the first factory one I've ever seen like that, and I truly don't know that they did that on purpose. When you get the replacement rubber, PTFE, whatever it is style seal for the small block, you can't offset the halves like that because the main section of the seal has these little tails built in. I went ahead and knocked the main bearing caps back in place. I'm checking their press in the block, which they all seem to have. On Mark's 318, 2 caps did not lock in correctly when I took it apart. And so I guess that's something I just always have to look for now. It's actually cylinder number 8 that's been eating coolant for ages and ages. And there are some interesting marks in here explaining that. The worry would be if we have a cracked block. I don't care if the head's cracked. I'm not going to reuse the heads. But if this bore is cracked, kind of sinks this whole program actually. The thing to look for would be weird stained discoloration in various spots. And we do have that. So a kind of squiggly bit there. And then there's a good bit down here, but I think that is coolant that was around the skirt of the piston, sat there for a while, and stained the cylinder wall. This kind of looks like it could be a crack, doesn't it? But it doesn't extend anywhere above that line right there. So I don't know. Over the years, I've opened plenty of engines that had blown head gaskets, and staining like this in the bore is not at all uncommon. I think it's probably fine. Wiped it out with some brake clean. You can still see the discoloration, but I'm not seeing anything that looks like a crack. So I'm hoping we're fine here. I do see an incomplete area of the carbon ring around the cylinder here between the bore and the gasket. Kind of sort of leading to this water port, but that's not all that uncommon to see. We've got a similar thing here and a similar thing here. Yeah. Here we've got the corresponding shiny marks on all of the valves that match what we saw on the pistons. Again, there's like no carbon, nothing over those marks to show any indication that this engine has run since that occurred. So I'm really thinking the timing chain jumped before it totally jumped far enough that the thing wouldn't run anymore, and we ended up with all kinds of valve contact as a result. Very interesting. When you know to look for it, the coloration of the intake port on number 8, where it was eating coolant, is even different. Obviously, all of them are kind of rusted at this point, but only this one is kind of yellowish greenish. Man, I would have bet you some serious bucks this was a cracked head, but I've cleaned the residue, I've wiped in here, I've lightly scraped. I can't find any cracks or anything that looks like obvious damage, except right here, near this water port, there's kind of a rough spot. See that there? But that's inside the fire ring. So what could that have to do with anything? I don't know. When you've got an issue like this, you really need to be able to diagnose and pinpoint the cause. Because if you don't, how do you know you're fixing the issue? If we still had a local machine shop, I'd already be on my way there with this cylinder head. I'd have it pressure checked. And if it failed that, okay, we have our answer. There would be some kind of crack in here allowing coolant to get into the chamber, and since we're not using this head, we're going to be 100% A-okay. But we don't have a local machine shop anymore, so I'm kind of on my own. I do see some evidence of combustion right at the top of this water port. Could it be that simple? Well, here's what I've decided to do. This thing needs a hone in any case, so I'm going to start by honing number 8 there. If the pattern looks nice and if nothing strange crops up, no chunks of the cylinder are like shifted out around a crack, no obvious shiny spots, and the pattern looks good, I'm going to say it's probably fine. Maybe this is a mistake. Maybe it'll hide a crack if there is one, but I don't know. I'm not seeing anything obvious, so I'm just going to send it. The last time I used the hone was for the Poly 318, which is why I couldn't find it. It's out here. Well, that's not even the actual hone. Where's the actual thing? Haven't found that, but I did remember where the other spring scale is. Here's a 318 piston and rod. If I can hold it steady, it's like exactly 1,600 grams. And there's 273. It's just under 1,600. Let's see, 1,500... 1550, 15, I don't know, 70, 80, it won't stop moving. It's really close, like really, really close. If I was worried about 20 or 25 grams, I could come in here and grind a little bit off these pistons. I'm not. Anyway, back to the whole honing thing. I remembered where that is too. This, of course, is my really nice Lyle stone hone. It's way better than those $16 Amazon pieces of junk. FYI, I only own this because I bought an entire machine shop once, then I sold the machine shop, but kept this. Okay, that made me sound like way more of a baller than I ever have been. It was a 30-year-old machine shop's worth of crappy used tools. Anyway, I'm going to use gas for honing today, because if Uncle Tony said to jump off a bridge, I'd ask which bridge and when. Whew, smells like gas for some reason. I'm going to try not to break any stones today, but I make no promises. See? What did I tell you? No promises. Oh, you bastard. Yep. I hate everything. Everything. Pretty sure I caused that shiny spot when I caught the hone down there. Got matching shiny spots over on the other side, so that's just great. You know, I noticed it wasn't really doing anything down at the bottom of the bore. Now I know why. How'd that even happen? There's that cylinder after a quick hone with the 180 grit stone. Looks pretty darn good, honestly. It's a little bit of shadow at the top. And then we still have this pattern. You can see that there, kind of, sorta. That is a shadow of the oil control ring. And I'm sure that's because the oil control ring in this hole was like constantly full of coolant. I know that doesn't really look the greatest, but you can't feel that with the fingernail at all, so I'm thinking it's fine. Most of these other cylinders look great, In fact, in a lot of them, you can still see a nice crosshatch, but I do think I'm gonna go through and hone all of them while we're here. And then this block needs the cleaning of all cleanings. Remember that time I threw my drill? That was funny, or actually kind of pathetic, but I've got this side done, almost actually. I could use a little bit more, especially this one. Notice it's got these shadows on the sides. That's kind of odd because the piston rocks this way. And so you expect to find your wear at the top and the bottom, not here so much. Don't know what that's about. You can see a little bit of ghosting in every one of these cylinders. There's quite a bit there actually. There's a weird little spot on this side. I don't know what that's about either. I don't know. Maybe I'll do more here, or maybe I'll give up because I'm tired of breaking hone stones. You know, I know exactly-ish how far it needs to go down there, but it's kind of hard to eyeball that when you're stroking the thing, and there's no stop that keeps it from going too far. So it's really easy to crash into the main saddles. Give it another run. It's down to just the faintest shadow on this side, nothing on this side, so I feel good about that, but I need to do the same to these two. There you go. This side is fully minty. Got my eye dialed in on the passenger side and switched back to the magic spray I normally use for this. Well, okay, it's PB today instead of WD-40. Anyway, the driver's side is going much faster, and it's coming out really nice. Even the rusty number 5 looks just beautiful now. See, this shadow is more like what I'd expect to see. As the piston rocks on its pin this direction, it slightly eggs the cylinder in this way. Oh, this guy needs just a skosh more. I'm tired of honing, Grandpa.
It's too damn bad!
Well, hey, it's not just good, it's good enough. Actually, that's really nice. That might be the best one. My back hurts. We've got a satisfactory hone job. Tomorrow I'm going to see if I can't con Allan into cleaning the crap out of this block for me, and then maybe we can start putting new stuff on it. Maybe. It's the next day, and surprisingly, I've got good news and bad news. Is the bad news about to grind this whole thing to a halt, you ask? Why, of course. It's like you've seen the show. I suppose we'll do the good news first. Earlier today, Allan put in several hours on this block, cleaning the crap out of it. The valley's looking good, and the outside is pretty clean too. It's not exactly pristine, but I'm impressed. All of this was just grease, grime, dirt, horribleness, and now it looks almost ready for paint. Although he blew out the main oil passageways, we have a lot more to do before that's ready to go. This is not final cleaned, it's just better, like a lot better. There's a big paint marking on this side of the block. I suspect this would have been letters for the individual piston sizes. That's usually what you see here, but I cannot make heads or tails of what that says. Kind of just looks like a big white blob. This side is marked EDEE on the pan rail. I don't really see that. There's a little bit of lettering. There's something. Maybe that was an E. I don't know. The honing job yesterday, of course, was extremely frustrating, so I am glad to come back to this today and see it looking good. So if everything I had determined and said yesterday was accurate, we'd be putting this thing together right now. However, I was wrong. Well, actually, I was right, and then I was wrong. As I've explained, the only reason the truck that donated this engine looks like this now instead of like a whole truck is because I found chunks of what I was sure was cam bearing in the bottom of the oil pan. Obviously, when I tore into this engine, I found this. And this is not the prettiest, but I don't know. Looking rearward at the other bearings, I thought, you know what? They don't look that bad. And I couldn't see any peeling or anything from this perspective, so I thought, we can just run them. Everything was still kind of greasy, but I did glance back here at the number 5 bearing, and it looks really good. So again, I was thinking everything was fine. I think because they were covered in oil, or maybe because I just didn't want to notice, I didn't see this. This is terrible. This is the number 4 cam bearing, and if the thing will focus, you might be able to see that it is indeed in pieces. Yeah, this perspective's the best, because you can see almost all of the coating is gone off of that. There's just a tiny little bit left. And number 3 is like almost as bad. Viewed from this angle, you could see how that might look kinda okay, but it's not. Number 2 is not as bad. It's not good, but it's not as bad. If one is so inclined, one can pop little sections of this coating off, which is pretty fun. Oops. Well, that's just a scratch. That's not as fun. Anyway, cam bearings. What a good idea. Now, replacing cam bearings isn't the end of the world. I've done this many times, in fact. I'm usually happy to let my machine shop do it. That way, if they nick one, I have someone to blame that isn't myself. I bought this cam bearing tool like 15 years ago? 14? I don't know. Anyway, when I was rebuilding my first engine, and I've used it many times since then. What I don't have, of course, is a set of cam bearings. And I ordered one, but they're like a day out, and it's currently Tuesday at 7 p.m. You may be thinking to yourself, Jamie, why didn't you preemptively order all of the bearings and stuff for that engine so you'd be prepared for this build? Well, that would require planning. I have a bunch of other builds in progress around here. I've got slant 6 cam bearings. I might even have big block cam bearings, but all of the small block cam bearings I have are already installed in blocks. Truth be told, I have many better things to be doing with my time, and this was just kind of a little side project thing. I was hoping we could just slam it together real fast with like no money and very little time, but now we're here to the waiting for parts stage again. Is it too late to just pull this engine and put that in the truck? Ooh, or maybe this one. So it's time to give up and do something else. But first, I want to go a little bit more in depth on what my plan is here, just so everybody gets an idea of what the combination is going to be. Again, the bottom end is nothing special. I am switching to a forged crank, but that's only because I've seen a cast crank snapped in half in a truck just like this one, and I want to avoid that if I can. I'm not balancing it, even though I totally should. We're just going to run it as it is after we clean the rust off. The pistons and rods are going to be the stock ones I took out of this engine. The rings are going to be the rings I took out of this engine. I'm replacing one rod bearing. I do need to unstick these ones. We'll get to that eventually. I'll be using a stock 318LA oil pan. The advantage to this over a car pan is it's actually a rear sump. It also holds a little bit more oil. That's kind of nice. We don't have to worry about oil running away from the pickup so much on those hard launches, which we'll definitely be doing in this Power Wagon. I do have one more factory windage tray, which is slightly smashed, and I even have a set of the special main bolts for it, but that really seems like overkill for this truck. Probably going to have to reuse the original pickup, which I will clean extensively. I'm going to see if I can't find a high volume pump to replace that one. I think I have a good one here now. The camshaft will be this used Comp 268H. You can look up the specs online if you're interested, but I believe it's something like 445 lift, and 268 is the duration spec. This is the cam I took out of the 360 in the truck. The lifters are still in order and ready to go back in place. Now, I've already mentioned I'm planning to use a closed chamber head for this thing. That is intended to raise the compression ratio somewhat. It's not like we're going to reach 10-to-1 or anything, but it'll certainly be better than the abysmal 8-ish to 1 this 318 probably started out with. Now, I actually have a few options for that. One of them sitting right here. These are the 920 casting number heads I removed from that 318 I found at a yard sale way back a month or two ago in that video called Trash or Treasure. I could use these, but I kind of want to save them for another possible 273 Commando build at some point. See, in more modern Chrysler closed chamber small block cylinder heads, there's a point right here. It's kind of like a heart-shaped chamber. These 920s and similar have a flat spot right here, and I'm pretty sure the Commando piston kind of sort of fits into that area part way. Magnum heads are an option. Those have closed chambers, and they're actually pretty darn good, at least for low performance deals like this one. Unfortunately, they use a special intake manifold and also a special goofy rocker setup. And by special and goofy, I mean it's a small block Chevrolet. Oh, I would also need a custom push rod, and I'm not about that life. This is a set of 302 heads. No, they're not for a Ford 302 V8. They're for a 318, but they have the casting number that ends in 302. These are the more modern closed chamber head I was just talking about, and as you can see, they do have that pretty massive point there. Now, these are not the greatest in terms of performance. They have a pretty restrictive intake port because these heads came on roller cam engines, and to accommodate the push rod angle, which changed, these holes were enlarged. So the port right here is very restrictive. In fact, my pointer finger can hardly fit through there. My thumb certainly cannot. For a truck, you know, for torque and fuel economy, they do the job. As you can see, these heads are in pieces. They have been for years. I need to get these reassembled. I'm actually going to put them on a different 318 at some point. Instead of any of those options, we're going to use something kind of special that's sitting right here. Cast your mind back a couple months to when a subscriber named Dan came to visit with his Challenger SRT. I did a test drive video on that car, which no one watched, but I enjoyed. On that road trip out from Missouri, he dropped these cylinder heads off. You might notice right away that these castings look pretty similar to that 302 head we were just looking at. The casting number does not end in 302, it ends in 714. It starts with 530. If you know Chrysler part numbers, which I don't, all that well, then you know that that 530 number is relatively modern. Random interesting note, apparently that same 714 casting number was found on Magnum heads. That is according to all of these people listing Magnum replacement heads with that number as a possibility. I'm not sure why this is, as it has to be noted the Magnum casting is significantly different. For one thing, the combustion chamber, not at all the same. They have a flat edge off to the one side. There's no heat crossover in this head, and all of the bosses on the ends are different. That is in addition to the intake mounting and the valve cover mounting surface. So again, this is not a Magnum head. Why they share a casting number? I have no idea. Essentially, what we're looking at here is an over-the-counter Mopar Performance version of the factory 302 closed chamber 318 head. These were intended for mild performance. They aren't X heads, but they certainly have a little bit more kick to them than the stock 302. For one thing, the valve sizes have been increased. Instead of the little teeny tiny 1.82 inch intake valves, these are 1.88s, borrowed from 360 heads. And the exhaust valves are 1.57 or so, up from the factory 1.5. Although this is very similar to the 302 casting, it's not the same. They actually changed it right here in this area to allow more room for this bigger valve and de-shroud it a little bit. Again, with an eye toward performance and to accommodate the larger intake valve, they did receive something of a porting job. It's not like it was insane or over the top or anything, but you can see things were smoothed out a little bit. The bowls look pretty nice, certainly nicer than a typical factory casting, and that valve stem area has been worked over a little bit as well. It did not get any enlargement or modification here at the inlet port side. You can see right here there's still a bit of a shadow surrounded by the mark from the previous intake gasket that was installed here. They did not knock down the pushrod clearance. Though obviously the larger exhaust valves were fitted, and I'm sure there was blending done to the seat for those, I don't see anything else that was done to the ports. There's still a little shelf thing right on top, and the whoop-de-doo here that runs under coolant. You can see the smog ports are plugged on these. On the other head, one of them just isn't there, but the other three are, and they're plugged. I believe these go-fast springs with dampers came on the heads. Dan told me they were specifically intended to match a Mopar Performance grind. He gave me the grind number for the cam those springs were supposed to match. It was the P4452761 cam. Advertised duration is 268, and lift is 450, 455. If that sounds familiar to you, well, it should, because it almost perfectly matches the 268H from comp that we're going to be putting in this thing. Although the numbers are fudged a little bit, the comp doesn't have the split lift, split duration of the purple shaft. It has the larger lift number on both lobes and the smaller duration number. Still though, very, very similar, and an operating range of 1500 to 5500 RPM, which sounds amazing for a truck. Actually, this comp is going to be a little bit more mild. Yes, the advertised duration numbers are the same, but at 50,000s, we've got 218, 218 on the comp. The Mopar purple shaft is 228, 231. They are both ground on a 110 lobe separation angle, by the way. According to Jegs, this comp is a replacement grind for the HP 340 and 364 barrel cam, so that's cool. They also say it will have a noticeable idle in a 318, which is excellent. So that's all good news, and it actually gets even better, because I've checked the valve seals on these heads, and they're still squishy rubber, so I don't even have to do that. I'm pretty sure all we're going to do is knock the chunks out of the ports, blow these things off, take these stock stamp steel rocker arms off, and bolt them on our engine. Obviously, my sincerest thanks go to Dan for styling me with these heads. This is going to be fantastic. I think I already mentioned I'm going to be running 273 adjustable rockers. Did I? These are my favorite, especially because I have like 3 sets at this point and they were all almost free. I've got a set of factory 273 push rods here, and hopefully they will work. Although, there is actually a slight difference between the height of a hydraulic lifter and a solid lifter, and we're going to be putting these on hydraulic lifters. It should be fine. As I've discussed many times, the reasoning behind using the adjustable rocker is to prevent lifter pump-up floating valves open. Because we're not going to be spinning this thing to 6,500 RPM ever, it's probably not all that important, but I have them. It gives me the warm and fuzzies. We're going to put them in there. So there's the plan. We'll take our freshly cleaned block once we get some bearings, reassemble the bottom end, slap these heads on with some cleaning, of course, and then we've got the icing on the cake. The Edelbrock Performer manifold, a random Carter Edelbrock carb, maybe this tiny silly air cleaner that was on the truck, but maybe not. And of course, the glorious Mickey Thompson valve covers with T-handles. Everybody loves T-handles. But all of that will have to wait for a future episode, which God willing will come soon. Hopefully some other things around here come soon, but we'll talk about all of that later. In the meantime, pay no attention to the elephant in the room. Hey, hopefully you enjoyed that. If you have any questions, comments, concerns, or constructive criticism, go ahead and drop that in the comments section. And I'll see you there. As ever, thank you very much for watching. And remember, you don't have to be rich, just smart. Not even that, really. Oh yeah, almost forgot. Opinion question. Am I obligated to repaint this the factory blue, which is correct for the 79 truck? Or can I do something different? I love to paint my performance builds Chrysler red. And though this one hardly counts, I think it would still be pretty cool. No, we will not be painting it Hemi orange. We've got plenty of that around here.